Engineering design, the thing you are here to learn. Engineering design is the ability to produce a solution to a problem which balances public health, safety, and welfare, as well as global, cultural, social, environmental, and economic factors. We can think of these things as dials which we can turn up and down at will, producing a solution. The thing that makes the whole process complicated is that all of these aspects are interconnected. Adjusting one changes the others, and for this reason, design is a cyclical process. Let's consider a bridge as a simple example. The bridge's job is to carry cars from one side of a ravine to another. Being a good-hearted engineer, you decide to build a bridge that is super safe. You use a large amount of materials that have a large impact on the environment and cost a large amount of money. Too much money. So after your initial design, you decide that you need to sacrifice some safety for cost efficiency and the environment. While doing so, you change some of the materials to ones produced locally, and now your construction practice benefits a company owned by an underrepresented minority. This reduces the global impact and increases the cultural impact. All of these factors are interconnected, and it takes multiple iterations to arrive at a satisfactory design. I want to stop here and make a point. For a long time, the main design consideration has been economic. When you work in the public sector for the government, you minimize the costs. And when you work in the private sector, you maximize profit. These practices have often come at the expense of the other factors. When you consider all of these factors, health, safety, welfare, global, cultural, social, environmental, and economic, maximizing positive impacts while reducing negative impacts, you are creating a sustainable design that benefits society over the long term. In the real world, you aren't free to design whatever you want. You have limits. We call constraints. These constraints can be set by laws, budgets, public opinion, or practical limits of fabrication and construction. They give you limits for your design. The engineering design process is often represented as a cycle with 5 different steps. The first step is to identify a problem. What are the needs and constraints? What problems would you like to solve? What are the boundaries for your solution? The second step is research. Is there a solution to your problem already? Has someone tried to solve it? How did they fail? How did they succeed? Learn from the past. See how things have changed. Maybe you can come up with a new solution now. The third step is brainstorm solutions. In brainstorming, no idea is a bad idea. Put everything out there and see what sticks. Once you have put out a bunch of different ideas, narrow them down and focus on one. Create an action plan to begin implementing the idea. The fourth step is to test your idea. This could involve doing calculations, building prototypes. It could even be a survey to determine if people like your idea. You need to find a concrete way to figure out if your idea will be a success. It is often very, very helpful if you use measurable values to test your idea. The final and fifth step is to improve your design. What worked from your testing? What didn't? How can you make it better? Have your constraints changed? What new topic does it give you to research? The cycle begins anew. The main point that I want you to take from this video is that the design process is a cycle. It is not a straight line to a correct answer. There is no correct answer, only acceptable designs. You work through the cycle until you have created a sustainable, acceptable design solution.